Welcome. In this session, we'll review the chain rule and a couple of rules that follow from the chain rule. Let's consider a couple of functions. Suppose we have two functions, and we'll assume that these are continuous and differentiable. F of t, and suppose we have g of t. So when we compose functions, what it means is we take the output of one and make that the argument of the other. So the composition is, and this is written in two ways. One is we could write f of g of t, or we could write f compose g of t. And some authors will just leave this composition as this little open circle, and some will put a big parenthesis around it, and it really doesn't matter. So the chain rule can be written in a couple of different notations. The Lagrange notation, what we would do is we would say that f compose g prime is, we take the derivative of f and its argument is the result of g, and multiply that by g prime. Or we could write this as f prime of g times g prime. Now these are the same, it's just that they look different. And if we use Leibniz notation, we would say the derivative with respect to t of f of g of t, now I have to keep all my parentheses straight, is the derivative of f with respect to g times the derivative of g with respect to t of t. And then, so this is the way that I prefer to write the chain rule. Now, what are some examples? So one is we could consider a function h of t, so I'm just going to add a third function in, and suppose it is 1 over, so that equals 1 over g of t. So now, if that is, so now what we can do is we can then start trying to differentiate h, and we can say that that is some f of g of t, where f of g equals g to the minus 1. That is, 1 over g of t is g to the minus 1. And here I'm purposely dropping the extra parentheses because this function f is a function of g, and it is g to the minus 1. And then we actually don't know at this point what g is, because for the purposes of the reciprocal rule, it doesn't really matter. Now, from the power rule, that means, that implies that f prime of g equals g to the minus 2 by the power rule, right? So we subtract 1, we have minus 1, and then we subtract 1, so that's minus 2, and then we take this power down in front, so that is minus g squared. And then applying the chain rule, what we get is that h prime of t equals, so that we had f prime of g times g prime, and that equals, so f prime of g, that is minus g of t to the minus 2 times g prime of t, and that equals, we can say, minus g prime of t over, let's put parentheses, g of t squared. So we can use the chain rule here to find the reciprocal rule, which is what's the derivative of 1 over a function. So we can then use these together, and we can say, what about a quotient? So a reciprocal is 1 over a function. A quotient is one function over another function. So now let's consider h, which is let's make that f of t divided by g of t. And if we apply the chain rule, the derivative with respect to t of f of t over g of t equals, so I'll let you work this out in detail yourself, because this is a really useful exercise. What you can think of is it's f of t times that reciprocal function, and when we do that, what we get is this is g times f prime minus f times g prime over g of t, and I'll put extra parentheses there, g of t squared. So from the chain rule, we can deduce the reciprocal rule, and we can deduce the quotient rule.